So now we'll suppose for a particular drug, we know that after the drug is injected, the concentration of 1.5 milligrams per minute, or milligrams per milliliter. After 4 hours, the concentration has dropped to 0.25 milligrams per milliliter. We want to find an exponential decay function. So the only difference between an exponential growth and exponential decay function is that k value. When we're dealing with exponential decay, our growth constant will be negative. So for this one, we have y of t equal to y of 0 e to the kt. I know that y of 0 is 1.5, that's the initial concentration. And I know that after 4 hours, so when t is 4, my concentration is 0.25. Dividing both sides by 15 gives me 0.1667 is equal to e to the 4k. I can take the natural log of both sides. The natural log of e to the 4k is just going to be 4k. So this gives negative 1.79 equal to 4k. Dividing both sides by 4 then gives my growth constant, or decay constant in this case, to be minus 0.4479. So our model, y of t is equal to 1.5 e to the minus 0.4479 t. Now let's figure out how much time is required for the drug to reach 1% of its original dosage. Well, we just had the model, y of t equal to 1.5 e to the minus 0.4479 t. So 1% of 1.5 is going to be equal to 0.015 milligrams per milliliter. So that's going to be y of t. And then I want to find t. So we'll start by dividing both sides by 15, and this gives 0.01. Or sorry, divide by 1.5, get 0.01, is equal to e to the minus 0.4479 t. We'll take the natural log of both sides to get rid of the e. This gives minus 0.4605 equal to minus 0.4479 t. Dividing both sides gives that t is equal to 10.28. So just over 10 hours, and we will have 1% of the drug left in our system. After this time we want to know what the half-life of the drug is. So the half-life is whenever we have half of the original percentage in. And just like our doubling time was the natural log of 2 over k, the half time is given by the natural log of 1/2 over k. So in this case, we already found k to be minus 0.4479. So we can do this calculation and get 1.55. So just over 1.5 hours, and we will have half of the drug left. So now let's suppose after 4 hours, we have after 6 hours, we have a second drug dosage given. We want to know how much time is required for our drug to reach 1 milligram. So we know the model. This is y of t equal to 1.5 e to the minus 0.4479 t. So first, let's see how much is left after 6 hours. So for y of 6, I have 1.5 e to the minus 0.4479 times 6, which gives 0.102. So after 6 hours, we have 0.102 left. So now we have a new model. After our second drug dosage, our initial is now going to be 1.602, the 0.102 we had left before, and then the 1.5 that we were given later. And so now we can check when we will have a single milligram left. So 1 equal to 1.602 e to the minus 0.4479 t. Dividing both sides by 1.602 gives 0.624 equal to e to the minus 0.4479 t. We'll take the natural log of both sides to get rid of the e. So the natural log of 0.624 is negative 0.471. And then we'll divide by the negative 0.4479 to get .05. So how much time is required for the drug level to reach 1 milligram? It'll be 1.05 hours after the second dosage. So if we consider it from the second dosage, 1.05. If we consider from the first dosage, 7.05.